All right, so here we have our new process. Again, this is kind of like a third method that we have, but it only works if you have a continuous function on a closed interval. So how are you going to know if it is a closed interval? It needs to be a square bracket A, B. You must see those square brackets. So the first step is going to be, again, any extrema question is always the critical numbers. And then now what we're going to do is we're going to compare those y values at the critical numbers and at the endpoints of the graph. So that's going to be step 2 for us, where we plug into the original function and then compare. So here I always think about closed is critical numbers and then compare. So it's like the triple C method: closed, critical numbers, and then compare. All right, so my first step is going to be, here is my function that's been given to me, and you'll notice that I do have a closed interval. So I notice that this is a closed interval, and I say to myself, okay, I need critical numbers, and then I need to compare those y values. So I'm going to get my critical numbers by taking the derivative. So that gives us 2x plus 2, and then set that derivative equal to 0. Again, this is not a quadratic equation, so I can simply solve by subtracting 2 and then dividing by 2. So that gives us x is equal to -1. With that -1, you'll notice that it is a critical number. It is interior inside the domain, and the domain here being -11 to 8. There is a little bit of concern with this section that you could potentially get a critical number that is outside of the domain. So you always want to double check that, like, yes, this -1 is in that interval before you start comparing your y values. So then what I do is I create my little t-chart where I have x and y, and I'm going to plug in my critical number of -1 and then my 2 endpoints of the graph. So the critical number again is the -1. The ends of the graph are going to come from this -11 and the 8. So they come from that square bracket quantity. Now, here's the deal. We are comparing y values. We are trying to find the height of the graph. So we are simply going to plug into the original function. We are not plugging in to the derivative. We are plugging into the original function because we're trying to find that height of the graph. So we'll have -1 first, plugging in for these x values. So -1 squared plus 2 times -1 plus 7. And you are more than welcome to use your graphing or scientific calculator to do this arithmetic. The key thing is I need to see that number line. And sorry, the sun is like shining so brightly, the morning sun. So I need to see, not that number line, I need to see the critical number process, and then you're plugging in to create this t-chart. So just drawing the t-chart is very important. All right, so that gives us the 6. All right, then we plug in our -11, our -11 squared plus 2 times -11 plus 7. Again, you can use your calculator to do this. That is totally, totally, totally fine. And that gives you 106. And then plug in the 8 squared plus 2 times 8 plus 7. So we have 64 plus 16 plus 7, and that gives us 87. Now, here is the deal with this. What we're trying to do is we are trying to compare the y values. So we are looking at this last column, and we're going to say what is the highest y value and what is the lowest y value. And those are going to give us our absolute max and min. So here, looking at 606.87, the smallest y value is 6. So that is our absolute. You will notice it's not relative here. It's now an absolute. Excuse me, that is our absolute minimum. And then the largest y value is this 106. So that is our absolute max. So, the way this is often written and communicated is going to be the absolute max is the y value at the x value. So, the absolute max is 106, and that 106 absolute max occurred at an x value of negative 11. And then the absolute min is 6, and that occurred at an x value of negative 1. And of course, filling in those blanks correctly is super important because that's how we communicate what the absolute max and min represents, and it will look very similar on your test, of course.